500. And I want to work out the upper bound for the difference. So the difference would be Cardiff take away Nottingham. And if I wanted the maximum difference, let's think about what you would choose. The maximum difference. Well, maybe if I pick Cardiff to be its maximum population, so it's upper bound, 350,500. And I want this difference to be as big as possible. And I don't really want to subtract that much if I want the difference to be as big as possible. So I'm going to pick the lower bound for Nottingham. That makes sense to me. Because I don't want to subtract much, I want the maximum difference. And then I type that into my calculator. And that gives me 37,000. I guarantee you could pick these four numbers in any order you like and do the subtraction, and you will not get a bigger difference than 37,000. What about a minimum difference, the lower bound? How would you achieve that? It's kind of the complete opposite. Cardiff, you pick the lower bound, which is 349,500. But this time you want to subtract as much as possible for the minimum difference. 314,500. Let's type that into the calculator. 349,500 subtract 314,500. You get 35,000. And again, I guarantee you can pick these numbers at the start in any order you like, and you won't be able to get a number which is smaller than 35,000. EG number 3. Let me give you a formula. C equals A over B. There's a slightly weird notation they can give you for upper and lower bound. Let's say the number A was equal to 2.3, but rather than say to the nearest to one decimal place or two significant figures or whatever, use this notation: plus or minus 0.1, and B is equal to 4.5, and again, not to the nearest decimal place or two significant figures. This is plus or minus 0.5. And I'm going to ask you to find the upper and lower bounds for C. Okay, so this might look confusing initially, but it's actually an easier way to write the upper and lower bounds. All this means is the lower bound for A is subtract 0.1, and the upper bound for A is add 0.1. Makes sense, plus or minus. Which means the lower bound for B would be subtracting 0.5, and the upper bound for B would be adding 0.5. And you got the lower and upper bounds already without even thinking. Right, this is where it gets a bit harder though. Upper bound, so let's go max value of C, C max or maximum C, upper bound for C. You've got a fraction. I want the biggest answer to this fraction. Okay, that would mean that the numerator, I want as much as possible. So I want the upper bound for A. But what I'm dividing by, the denominator, I want that to be as small as possible. I don't want to divide by much, because because I want the maximum answer, the biggest answer possible. So I pick the lower bound for B. Biggest possible on the top, lowest possible on the bottom. That would produce the biggest fraction overall, the biggest answer. Bigger the denominator, the bigger the fraction. Bigger the numerator, the bigger the fraction. The smaller the denominator, the bigger the fraction. Okay, 2.4 divided by 4 is 0.6. Okay, minimum C. Okay, this time I want the smallest answer. So the smallest answer would be smallest numerator. Don't want to share much out at all. So 2.2. And the denominator, I want to divide by as much as possible. If I want C to be as small as possible, I'm going to divide by as much as I can. And the upper bound is 5. So 2.2 divided by 5. 0.44. Okay. Now, exam tip I can give you for these questions, for these applications. Very easy method, Mark, is to write out the upper bound and lower bound of each value in the formula. Just like I did for Cardiff and Nottingham, wrote out the lower and upper bounds, just what I did for A and B in this. And then pick the correct combination to work out the upper and lower bounds of the formula. You do have to use just a bit of logic for this. There's nothing that works for everything. It's just if you've got a fraction, you want to make the fraction as big as possible, then obviously you want the number at the top to be as big as possible and the number at the bottom to be as small as possible. And it's just as easy as that. Okay, in terms of what I want you guys to do, so we're looking at exercise 3-star, which is on page 307. So we've got page 307. It's called exercise 3-star. I don't want you to do everything. Okay, we'll go for question 7, question 9, question 10, question 11, and question 13, which is really tough. And that's pretty much it. So if you get stuck with any of these, let me know and I'll do a video for the answer.